Hey everyone, welcome to the most opinionated space podcast on the internet.
Ad Astra, the podcast where we integrate space, policy, and technology.
I'm Jack.
And I'm Newton.
I have a Master's of Public Policy degree with a concentration in science and space policy.
And I'm a PhD in computer science and an all-around tech geek.
Okay, guys, don't forget to follow us on Twitter at @AdAstra_podcast, like us on Facebook, and subscribe to our mailing list on elemental.fm to get regular updates from the team. And if you like what you hear, give us a 5-star review on iTunes and recommend us on Overcast.
And today we're going to be talking about the sad status of NASA's asteroid redirect mission and the Planetary Protection report. In the space news highlight of the week, we'll talk about new exoplanet discoveries from Kepler. In international news, we're talking about Macron trying to snag scientists from other countries, mostly the US. In latest in tech, we talk about the new startup ThrustMe, and we'll talk about NASA's upcoming informational webcast about the August solar eclipse in Coming Soon to Space.
Ooh, that's not going to be one you're going to want to miss.
No, it will not.
So let's start off latest from Washington. So, Newton, what did you do Friday through Sunday this last weekend?
Friday through Sunday. It was a pretty normal Friday through Sunday. You know, I watched people walk around dressed up as, Wonder Woman, Harley Quinn, Batman, that sort of thing. We went to AwesomeCon. Ad Astra was at Awesome. Ad Astra was at AwesomeCon, and it was awesome. So, Jack, did you get a chance to get outside of the Planetary Society booth and actually walk around for a little bit?
No, absolutely not. No, yes, I was able to walk around a little bit. AwesomeCon is, like you said, awesome, but it's so much more. Unlike a lot of Comic Cons, this is what, the 5th year of AwesomeCon?
I believe it's the 5th year. Yeah.
So unlike a lot of Comic Cons, if you've been to those or Umicons, it's not solely comic books or solely TV shows or solely movies. It's all of that as well as much, much more. So like Newton said, I was with the Planetary Society, tabling there for them. So there's a huge section there dedicated to nonprofits and government organizations. NASA was right across from us. The Air and Space Museum was across from us.
NSF as always.
Yep, NSF is there. Nice. Everyone's giving away cool swag. It was absolutely awesome. I keep saying that, like thinking that it's not a pun, but it is.
Right.
But
it happens.
It really is. So if you have a chance to go to AwesomeCon next year, make sure you do it, even if it's just for a day to see 1 or 2 panels. Newton, you were able to actually sit in on a couple panels.
Yeah, I sat in on a bunch of panels. Both. I mean, I'm interested in all 3: comics, sci-fi, as well as science. I think I like science a little bit. I got to see
little bit,
just a tiny bit. I got to see James Mathers talk about the James Webb Telescope and sort of our history of peering out in space. I got to they had an entire section of the con, an entire series of panels called FutureCon, which is basically a con inside of a con, and within that con, they Star Talk Live was performed by Chris Hadfield. That was Friday night. They had multiple presentations from people all over NASA. I believe DOE was there, some NSF folks. That was pretty great. And then I got to see some of my favorite comic book authors, Scott Snyder. I got to see Jason David Frank, of all people. It's pretty random. And someone may or may not have gotten his picture taken with Stan Lee. So,
why is that not your profile picture on Facebook?
It will be. I'm trying to scan it. It's an actual picture.
What? Yeah. What do you mean? Like it's like on Instagram?
It's physical. Or? No. Like, so back in the day, we used to like print pictures out on actual paper for people to just like have.
So that's why we have climate change. Okay, yeah. I get it.
You're welcome.
So from what I heard about FutureCon, it was absolutely awesome. Chris Hadfield, of course, did his special episode of Star Talk Live, which is coming out soon.
His first episode hosting Star Talk Live.
Yeah, that's awesome.
He did a damn good job. So
kind of surprised he didn't break out the guitar and do some space oddity.
Spoilers. And at that presentation, there was a hologram of Stephen Hawking. They did the Tupac hologram for Stephen Hawking. It was pretty awesome.
It should really just be called NowCon at that point. I mean, it
really should. I mean,
the future's already here. Right. That was something that we talked a lot about to people at the booth. Was just how quickly the future is here. I mean, like 5 years. I got pretty involved about 5 years ago, and it's already I've seen so many more technological advancements in those 5 years. I sound back in my day, I sound like I'm a baby boomer, but I'm not. But FutureCon, it sounded like a lot of fun, but I was on the front lines talking to people, evangelizing science and space exploration. That was a lot of fun. So if you have a chance,
I was going bankrupt walking the exhibit halls, buying all manner of nonsense.
So yeah, if you get the chance, make sure you come to AwesomeCon next year. I think it's April 30th.
No, I think it's going to be even earlier.
Oh, it's March 30th through April 2nd, I think.
Yeah,
something
which is
like that.
Crazy early. This is the earliest they've ever done it. I'm not sure.
Why
it's that way. Listeners, comment if anyone's aware. I'm sure I can look it up.
My theory, the running theory, I guess, among everybody that I've talked to, is because Science and Engineering Festival is in late April. So they're trying to beat that. They're trying to be like the first thing that people go to with science, and then Science and Engineering Festival is like 4 weeks later.
I find that hard to believe.
Well, I don't know. There's got to be some. I mean, why would they switch the schedule up? I mean, everyone knows.
I don't know. That's
the first 2 weekends of June are always AwesomeCon, and then suddenly the sixth year, it's like, oh, it's not.
That's really strange. I don't know.
Yeah.
We'll find out. Otherwise, listeners, comment and let us know if there are listeners out there that know why AwesomeCon is going to be 2-3 months early next year. But anyway, moving on. You know what else? What isn't going to be 5 years in the future, Jack?
or 10 or 10, 15? Are you talking about the Asteroid Redirect mission?
That's exactly what I'm talking about. It's gone.
So the sad news out of Greenbelt, sad news out of Goddard is that the Asteroid Redirect mission, the idea, I mean, they were in a couple phases through the project already and developing the technology to capture a near-Earth asteroid and bring it into orbit of Earth and send astronauts there. It was going to be another stepping stone towards either the moon or Mars. It was sort of that halfway point between low Earth orbit, which we've got down pretty well, and cislunar space or Martian space. So yeah, the news broke just this last week. I think June 13th, there was the Small Bodies Assessment Group at NASA headquarters talked about how there is no hope for ARM in the future. ARM was actually cut from the budget last year. So this is sort of them, closing up shop. They're taking all the technology that they have already developed and seeing where it could fit in with future projects or ongoing projects. But this was something that within the community, both within the space policy community and within the technological community that I've heard of, that no one really wanted ARM necessarily, but it was a good stepping stone for doing that, the lunar mission or doing something in Martian orbit, it's sort of doing all that stuff before. So it was a proving ground that was separate from that Mars versus Moon debate, which we talked about a couple weeks ago, is not, after the H2M summit, that it's not really a debate, but it is a pretty significant policy question as to whether we spend, the next 15 years aiming for the moon and then hope that also gets us to Mars or goes straight from Mars. This was supposed to be that in-between space that it was supposed to be a very low risk. Like, you're bringing an asteroid into orbit. People, I remember when the program was announced back in, I think it was 2013, that, the news media went crazy. Like NASA's bringing an asteroid into orbit. It's going to destroy us all. And it's like, no, it's going to be a small asteroid. It's like barely going to have its own gravitational pull of itself. And it's just going to be a proving ground for human exploration technologies. But it had support in Congress for that first year, and then it just declined pretty quickly.
Right. And I mean, one of the things is so the asteroid redirect mission was just a part of what's called NASA's Asteroid Initiative. And the Asteroid Initiative is just an overall program in which they're trying to understand asteroids within our solar system, both from a defense standpoint and a where did we come from standpoint, to better understand the nature of the solar system and how the solar system came into being.
Well, those are some of the oldest objects in the solar system.
Exactly.
So that would be like where you would find the evidence for what happened in the early, centuries of the solar system. Keep in mind,
this is all the stuff that didn't become a planet.
Yeah.
That's effectively what this is. But other elements of the Asteroid Initiative are still out there. Things like the Asteroid Grand Challenge, which is their program to find all asteroid threats to human populations. Anything that is they want to find things that are less than 300 meters or less than 100 meters, because the big things we sort of have a grasp on. We can find a number of those, but how do you find and track things that are smaller than 300 meters, which estimates suggests are less than 10% of the objects in the solar system, or the less than 1% that's 100 meters or less. Those things slamming into Earth can still cause a little bit of damage.
Those are the city or county killers,
right?
Well,
maybe not a killer, but they'll
purveyor of mass destruction.
Let's go with a city the size of DC. Okay, so not very big.
So a medium city killer.
Yeah. DC's kind of more like northwest and southwest.
That's still about that range. That's still kind of big.
That's true. That's
like
that's fair enough.
That's 40 square miles. That's kind of a lot.
I won't debate Armageddon level catastrophes with you. But
don't make me get Bruce Willis in here.
So programs like that in the Asteroid Initiative are still going on, but it is sad to see this one go. But like you said, it's something that not a lot of people were necessarily sure that we were going to do in the first place.
Yeah.
Their hearts weren't in it.
Yeah. Well, so here's the thing. Here's my opinion, my hot take on the Asteroid Redirect mission, is that if we had a space program that wasn't hampered by the budgetary constraints that we put on it, not that Congress doesn't support the space program, they just don't support it playing the role that a lot of space advocates imagine it could. So a lot of people who are in the space community talk about, oh, well, if NASA had the budget of DoD, we'd be able to do all these great things.
Never gonna happen.
But yeah, it's never gonna happen. But also, that's just not in line with national priorities. That's not in line with the culture. I mean, it's something like 60 to 70% of people support increasing NASA's budget every year, and a lot of that. I think it's still over 50% support even doubling NASA's budget over a certain period of time. But it's just not feasible, right? That to convince Congress, who are under immense pressures to make cuts, are going to say, oh, there's this program that comparatively speaking is small. I mean, it's a little bit over 18,000 employees. It's less than 0.5% of the federal budget. That's going to be the saving grace of the United States. And I mean, you could make the argument that it is. I mean, you can talk about return on investment. You can talk about spin-off technologies all you want, but that's not going to get through to members of Congress and not going to always get through to the public. So if we were in a better budgetary context, if we were in a better time, if we actually cared about being smart, maybe we would do ARM. And if we wanted to understand where we're coming from in the universe, we would do ARM. But right now, just, I guess, isn't the time. And it's also being labeled as an Obama program. So, and you know how popular Obama is on Capitol Hill right now.
Thanks, Obama.
Thanks, Obama. Well, you know, like Dan Mazanek, the ARM mission investigator, says, somehow a form of ARM may arise in the future. I think still that it is a good mission. And I agree.
I'm sure it will. Yeah.
I'm sure this technology will emerge at another time. Anyway, next topic. So, actually, last night I got to see the Bill Nye documentary.
Oh yeah, how was it?
Speaking of saving the world, so
did he save the world yet?
Not yet. That's why we still need him. That's why he's out there. That's why he's fighting for us. Like, seriously, this is probably the greatest documentary that I've seen in a very, very long time.
Really?
I mean, the thing is I went in kind of expecting something. I kind of just expected that it was going to be a history of the Science Guy show. And then it was going to be, and then he disappeared for 10 years and he was doing some things. And then boom, here he is again. And he's back to save the world. But from watching it, I don't want to give anything away, but they do conflict very well. So David Alvarado and Jason Sussberg are amazing filmmakers, and they're able to show the strife that is affecting him professionally. So talking about the Ken Ham debate, talking about Joe Bastardi, that meteorologist guy, he plays a role in the film. You know, talking about, you know, the Bill public persona, but then it also talks about him privately. And so he, you know, Bill was there. I got a picture with him. I got to talk to him a little bit. So it was good seeing him. But in the film, he is vulnerable. You know, he opens himself up to public scrutiny again, and he keeps doing this. And he, like, throughout the entire film, and then talking to him afterward, it just seems like everything that he does is for this mission of saving the world. I know, and it's so cliche to say, oh, save the world, all this, but like, I've never met someone who firmly embodies or believes in something more than I've seen in Bill. So if you have the opportunity, so PBS picked up the film and they're going to be doing their major release in November, but they're still doing the festival circuit. They were just in DC. I think they're going to be doing a couple of other festivals here in the US on the East Coast. So make sure you get to that. I mean, it was amazing. So if you have, Newton, if you have to road trip to go see it, I'll come with you again, because it's just
is that worth it? It's that worth it?
Absolutely.
Oh, okay.
Absolutely.
Okay.
I'm gonna be a Bill Nye evangelist for forever.
So I just pulled up a list of the top 10 documentaries, or the top US grossing documentaries of all time, and I want you to tell me which one of these
which one is it comparable to?
Yeah, which one of these is it comparable to? So apparently Fahrenheit 9/11 is the top grossing from 2004, the Michael Moore documentary on 9/11. Better or worse than Bill Nye?
I don't know if I can be extremely objective, just because well, maybe I can be, because I love Michael Moore and I love Fahrenheit 9/11. Love is a very strange word to be using with a film that details the horrible incidents of that day. But I don't know. I do think that the Bill Nye film does do. They hit different categories for me, though. They're both documentaries, but I guess the Fahrenheit 9/11 is more investigative than the Bill one. The Bill is I mean, it's just a glimpse into his life and his history. So,
better or worse? This is a lightning round. Come on.
all right. Give me another one. Just do another one. Not
all right. We'll come back to Fahrenheit 9/11. Jackass 3D.
Oh, way better.
How is that a documentary?
I didn't even see that. I don't even think I've seen a single. I think when Jackass was on MTV, I've maybe seen one episode. And I know for certain the Bill Nye documentary, Bill Nye Science Guy, is so much better. I should actually call it by the correct title.
Keep in mind, I'm going top U.S. grossing documentaries. All right, that doesn't mean best.
Okay,
because that's subjective. All right, Space Station 3D. It's the first 3D live action film to be shot in space.
Is that the Smithsonian one?
Wait. Was it?
I thought it was, or at least
I thought it was. It's starring Tom Cruise, though.
Oh, the Bill Nye film's better.
Film also includes sequences that portray the force of a rocket launch. Interesting. I've just never seen that one. Yeah, we'll go with Bill Nye on that one. All right, just a few more. March of the Penguins.
Better. I like penguins, but Bill's better. Bill goes to Antarctica too in the film. So
Everest. An international team of climbers ascends Mount Everest. This was a 1998 documentary.
I don't think I've seen that one.
Journey.
No comment. No comment.
Okay. Justin Bieber, Never Say Never.
Oh man, Jay Biebs, like he's my man. Like
that's hard.
That's such a hard choice. Bill, come on.
Okay. Jackass number 2. What the hell, America?
I think this ties into a later story about making America smart again.
It really does. This Is It, Michael Jackson. Ooh, that one.
Bill.
Yeah, I'll.
See, here's the thing. I've never been. People are going to kill me for this, but I have never been the biggest Michael Jackson fan.
Moving on.
It's King of Pop. I like it, but it's not. It's different. It's not enough for me.
All right, 2 more. Hannah Montana and Miley Cyrus, Best of Both Worlds concert. What qualifies as a documentary?
So So where is this list coming from? Are you just pulling up some web
IMDb? This is IMDb. It's the top U.S. grossing documentaries, though, which I can see why those are the top grossing.
Well, yeah, because it's shitty entertainment. Of course, it's going to be high grossing.
Can you guess what
put into it?
Can you guess what number 10 is?
I don't know. What is it?
Jackass the movie, the original.
Oh my god!
Thank you, America.
Thanks, America.
And as a bonus, I'm going to read number 11 and leave it alone. In Search of Noah's Ark. Moving on.
Oh. In Search of Noah's Ark is better than the Bill Nye film. No, I'm kidding.
For sheer entertainment.
I want to get that quick. I want to get that as our soundbite for this episode, and Ken Ham can endorse us, and we can take some of that Kentucky tax money too.
Oh, yeah. Actually, you're absolutely right. In Search of Noah's Ark is better than Bill Nye's film. Tell the world.
I am absolutely kidding. David, Jason, you did a wonderful job with this film. Bill, it was great seeing you the other day. And moving on to our latest from Washington little tidbit, the National Academies of Science just released an interim report on planetary protection. So this was a topic we brought up the last couple of weeks. There was the COPUS, the Committee on the Peaceful Uses of Outer Space. It's a UN committee. They met in Vienna this last 2 weeks, basically last week and the week before that, talking about planetary protection as one of the many things that they were talking about, which we will be getting a guest on here who went. But the National Academies put together a 24-page, really quick sort of interim report detailing what planetary protection is, why it's important, and further goals that I guess that they're setting for the national academies as well as the United States and the international community to address. So in it, they talk about the goals of planetary protection, protecting other planetary bodies from contamination, So if we send a spacecraft somewhere, making sure that microbes on there don't contaminate that and ruin a lot of the science that could be done on these natural bodies. There's only so many objects in the solar system, and there's only so many big objects that have the potential for supporting humans or supporting human-built exploration. So, I mean, like, obviously, we just talked about the ARM program getting canceled down. So, there's not going to be some little tiny asteroid that we're going to be like, oh, that's our last place that we haven't touched in the universe, like, or in the solar system. Let's go there. There's going to be no public support for that. So making sure that the places we go, so Europa, Enceladus, Mars, Venus, remain uncontaminated by Earth microbes, Earth bacterium. Also goes into the rationale, sort of coming from the scientific perspective and the legal perspective, talking about Article 9 of the Outer Space Treaty. And then going on, the last thing that they talk about is additional work needed, which includes a call on the COSPAR, which is the Committee on Space Research, to come out with guidelines, which I'm fairly certain they've been working on anyway for a while, on what terrestrial space programs need to keep in mind when building spacecraft going to other planetary bodies. And also, National Academies calls on the United States government and NASA to develop guidelines and policies that are in line with some of the findings they have here, and that will be in the final report coming out in the next couple months. So this is a very interesting topic that's developing. And if you're really interested in life on other planets, or really interested in human exploration of other planets, planetary protection is one of the hottest issues right now. It might not seem like it, but the hottest thing in the universe of space policy right now might actually be microbes.
Some might say that it's our prime directive.
Star Trek Discovery comes out on September 24th.
Coming off of AwesomeCom, guys. I'm sorry. But yeah, no, I think I definitely think it's an interesting topic. It will be interesting to see how this gets reworked about 10 years from now, when we're really focusing on, all right, what's going to happen when we get humans on another celestial body for the first time in decades, right? Like, and I'm assuming this report is just going to get revamped. I don't think it'll change too much. I think there's just going to be a lot of addendums to it. Once absolutely. We actually have to do that.
This is going to be something that gets reiterated over and over, especially as we start getting closer and closer to human exploration of Mars. I mean, because planetary protection doesn't necessarily affect the moon as much, or these policies don't affect the moon as much, because it's not necessarily a life-supporting ecosystem on the moon. We haven't found any life on the moon. It doesn't seem like life can exist on the moon in large capacities, but Mars at one point probably had life. So if you send a couple tardigrades over there, and then suddenly there are trillions of these tiny, microorganisms, that almost invalidates all research into life on Mars, which we don't want to do that, because we're going to spend so much money to get there. And that's one of the prime reasons we're going there. And then suddenly it's not the case that we can do any astrobiology research there. And then that just pushes discovery of alien life further and further out.
True story. All right. Well, I'll be interested in seeing what happens with that.
Speaking of further and further out, I think probably the biggest story since TRAPPIST is this one that you're gonna bring up, Kepler.
You mean the biggest exoplanet discovery since the last exoplanet discovery?
It seems like every week they discover a new exoplanet. I'm like so happy I can say that and it be somewhat true.
I know, honestly. So, let's tell the people what we're talking about. So Kepler
fill you guys in a little bit.
Kepler found 219 new exoplanets. So NASA's Kepler Space Telescope team just released a mission catalog of planet candidates that introduced 219 new planet candidates, 10 of them which are near Earth size and orbiting in their star's habitable zone, which is the range of distance from a star where liquid water could pool on the surface of a rocky planet. even though none of these that I believe have been confirmed yet to have liquid water. As they always mention, this is the most comprehensive and detailed catalog release of candidate exoplanets. That was NASA's statement. Now, as a reminder, the Kepler Space Telescope looks for planets by detecting a small, minuscule drop in a star's brightness that occurs when a planet crosses in front of it. That's called a transit. And the interval between transits can be used to figure out the planet's orbital period, from which estimates of its orbital semi-major axis using Kepler's laws, and its temperature using models of stellar radiation can be calculated. Kepler orbits our sun every 371 days, and as it travels, it keeps itself pointed at a single patch of the sky. It has an array of about 42 camera sensors that specifically are designed to detect those transits. And those sensors can actually monitor the brightness of 100,000 stars simultaneously. And that's the crazy thing. Remember, the Milky Way has an estimated 200 to 400 billion stars, okay? That means Kepler is only looking at 0.025 to 0.05% of the actual Milky Way, which, as it goes in astronomy, is both tiny and freaking massive at the same time. Right? And in much the same way, discoveries like these are becoming more commonplace to the general public, but freaking exciting at the same time. I mean, it's like you said, another grouping of exoplanets. Like here's some more news. So
I think it was Emily Lakdawala at the Planetary Society who I saw a tweet of hers, and she was like, I can't keep track of them anymore. I used to have all 10 of them memorized, and now there's over 4,000 candidates.
Well, that's the thing. Yeah, there are 4,034 planet candidates that have now been identified by Kepler,
with 2,300 of them being confirmed as planets, and that includes the TRAPPIST system, all 7 of those. Right.
So yeah, through modeling, through calculation, through analysis of the star's orbital velocities, we've been able to verify 2,335 of them as actual exoplanets. So 4,034 candidates, 2,335 verified, and of that, there are roughly 50 near Earth size habitable zone candidates that have been detected by Kepler overall, and more than 30 have actually been verified. And new planet candidates continue to be found at all periods and sizes due to continued improvement in detection techniques. And keep in mind, Kepler was just the first NASA mission that was actually capable of detecting Earth-sized planets. That's incredible. That's incredible. This is our first shot at doing this. And we've already got 50 candidates and 30 that have been confirmed.
So rocky planets, and that's sort of the distinguishing factor here is the Earth-sized ones are rocky planets. These are the ones that they go through
a nice 1980s montage.
The eye of the tiger. Yeah. Tom, throw a clip in there if it's not copyrighted. Yeah. So this 50 Earth-size candidates, and then 30 confirmed, with 3 of which I'm assuming are the TRAPPIST, 3 through 6 or whatever it is.
Yeah, because
it's TRAPPIST 1, and then they all they're assigned the letters, so it's TRAPPIST 1.
Yeah, the TRAPPIST 1 is a
D
star
through F.
And then yeah, I think
so.
Yeah, Kepler has this sort of unique ability to detect those smaller planets. And in particular, I was checking out some of the infographics on the NASA mission site after the webcast, and they're looking at ones that even have these long orbital periods of more than 100 days, moving around their sun or their star, and their data now allows researchers to study planet populations that make up different groupings that make up different groupings of planets, gas planets, lava planets, rocky planets, that sort of thing. And they've just discovered a number of a number of vastly different types of planets, enough to them to identify gaps in the distributions of planet sizes that are out there. And so far, those planet sizes are falling into two distinct classes: the rocky Earth size and the super Earth size. And actually, there's three, and the mini Neptune size apparently, which is simpler. That's the one that's similar to Kepler 22b, that one of the first ones that we discovered that was Earth-like. So yeah, there's a bunch of cool histograms and infographics on Kepler's website. Check it out. They're doing great work.
They're doing amazing science.
They are doing amazing science. And
I just still think it's so awesome that they're able to detect a planet or a planet candidate just by its transit across its star. So if anyone's ever seen like the transit of Venus or Mercury, how you see like the dot move across the sun, imagine being able to detect that from like 40 light years away, which is, like an unimaginable distance in like our own like thought in our own minds. I mean, just think about it. The distance between us to Mars is 23 light minutes. So multiply that by, thousands and thousands, and you get a light year, and multiply that by 40. That's an insane distance. And then you can detect a little object going across the star, and then can figure so much more stuff out of that. I mean,
it's your calculus 3 class put to work, basically.
I mean, so that is just awesome. Now, some of this research, I'm sure, will be coming out of France soon enough.
France thinks so.
France definitely thinks so, because they want to make our planet great again.
That they do. So in response to the U.S. president, whatever his name is, his decision
tweets a lot.
Yeah, Mr. President tweets a lot. In response to his decision to withdraw from the Paris Agreement, Emmanuel Macron, the newly elected president of France, he's trying to entice scientists, specifically calling out those in the U.S., to come to France and do research. On June 8th, the French government unveiled a website aimed at doing just that, at attracting foreign scientists by offering 4-year grants worth up to 1.5 million euros each. For those who haven't been paying attention, the Paris Agreement was supposed to, it's going on without us. It's the first global comprehensive climate agreement ever. We've never done anything like this. And it sets a series of goals for reducing emissions, acknowledging that natural disasters will disrupt all of the world's countries if we do nothing about climate change. The Paris Agreement sets out a global action plan to put the world on track to avoid dangerous climate change by limiting global warming to well below 2 degrees Celsius by the year 2100. That's its goal. And to date, 195 UNFCCC members have signed the agreement, with 148 of them ratifying it. The U.S. withdrew from the agreement on July 1st, with Secretary of State Rex Tillerson commenting that the president was not walking away from the science community whole hog. He was just saying that Trump believes climate change is still important and wants to stay engaged on the issue. Anyway, as stated on the website, faced with the climatic skepticism of the new government of the United States, President Emmanuel Macron invited American scientists to come work in France. And for those who think that this is purely politics and not passion, Macron seems to be pulling in a ton of scientists and mathematicians to help get this initiative started. He's actually got quite a few supporters already. Science Magazine recently talked to one of En Marche's new National Assembly members. He's a mathematician and Fields medalist by the name of Cedric Villani. He's 43. He's another youngin' like Macron, and he won 69% of the vote recently in a constituency south of Paris. That's Essone's fifth constituency, for those who are wondering. Villani heads the Henri Poincaré Institute in the capital. He's won a book prize from the American Mathematical Society back in 2014 and joined the Pontifical Academy of Sciences last year. And he's become one of France's best-known scientists due to frequent media appearances over the past decade. Instead of sporting a bow tie, he typically rocks a trademark silk ascot and a spider brush. When it was mentioned that part of the scientific community was yet to be convinced that Macron was really interested in science and that, you know, it's just politics and that and that this is really him just taking advantage of an opportunity, Villani stated that, you know, he's a president who believes science is a part of global politics. There's a way to work together in effect. And if there is enough money in the system, a good balance between basic and applied research and good governance, in other words, if the system works, chances are that the scientific community will be happy in the long run. So that's if they can, that's if they're able to actually, you know, pull off building up a much larger science infrastructure than the one that's currently in France. France does have a significant number of scientific capabilities, but they aren't like the US, and in a number of ways. One of the biggest ways that was brought up in a recent conversation that I had was pay scale. You know, a lot of people come to the U.S. A lot of scientists come to the U.S. because you get paid more for doing science here. However, if I'm a PhD just graduated, just wrapped up my dissertation, and I have an opportunity to do a postdoc, or I'm just getting past my postdoc, and I see this as an opportunity, and I see that this is available as an opportunity, that's pretty enticing. To have 4 years of a grant paid for, and I get to live in France for the next four. I
hear they have pretty decent food and wine.
Yeah, I heard their food and wine's okay. So actually, as far as the details, I actually put my info into the site because the site's kind of abstract. It doesn't give a ton of information, but I actually put my own details into the site just as an experiment, not going anywhere.
Good. We can't deal with the time difference. We can barely coordinate a recording.
Hey, we already did it twice. Well, no, we did it once when I was in London.
Yeah.
But yeah, God knows I would never leave and go to France for 4 years. No. So if you're an experienced researcher, junior researcher, or a PhD candidate, it looks like this is available to you, or at least that's what it was stated when I put my information in. And one of the things that it showed was if you're a senior researcher, and that's a faculty member with a 15-year track record or so, you can get 1.5 million euros for a 4-year grant that includes salary, 2 working staff, 2 students, and working expenses, which allow you to develop projects that benefit from that benefit from the hosting laboratory environment. If you're a junior researcher, and that's people that are a few years outside of their PhD, you get 1 million euro for a 4-year grant, a salary, 2 PhD students, and working expenses. And that also allows you to do the same, to develop a project that benefits a hosting laboratory environment. So he's really trying to make this enticing and snag the few PhDs that we have here in the US.
Yeah.
So
just a few, just a handful of just pepper in a couple PhDs. So how do I become a senior researcher? How do I get,
according to them,
a PhD and 15 years of experience in like maybe a week?
Well, no one knows how to get a PhD, and it's great. This is interesting. I think it's interesting. It's one of those things where France, they have great research opportunities there already. They don't pay as much, but like I said, if your science isn't all about pay. Okay, I'm not saying that to say, oh, scientists are altruistic. No. When you're like 15 years in and you're worried about your family, it's about pay. But honestly, most people coming out of their PhD, they're still in college mode. You know, they plan on being broken in a postdoc for the next few years. This is a good opportunity for the one, particularly for the ones who are studying environmental sciences, climate sciences, atmospheric sciences, any sciences. I don't think I mean, maybe they'll get to the point where they're doing, computer science or something like that, but I don't think they're going to get to that
astrophysics.
Point. Or astrophysics. But I think they're focused on, well, the three that it said here are climate change, Earth system, and energy transition. Oh, so renewable energies. If you have renewable energies experience, they cite zero carbon energy sources, energy storage, smart energy management system, hydrogen vector. This is them killing two birds with one stone. This is kind of Macron sticking it to Donald Trump and actually trying to adhere to the Paris Agreement. So,
well, I mean, if you think about it, they're, even if they only get one PhD graduate or, a PhD scientist to come over, if you have two scientists studying under, or two PhD candidates underneath you, that's then two more people who are going to get so sort of some oversight, some mentorship from someone who's coming from one of the best paid, best set up science programs in the world.
Right. The long-term effects of this are actually interesting because, I mean, so while our education system below 12th grade and below is not good.
There are a couple other words, nice. But my less than 12th grade education wasn't good enough to tell me what those words mean.
Right, exactly. While our education system 12th grade below is not great at all, on average, by the way, not great at all. Our university system's still the best in the world. Like, for a large number of subject matters. So now this is a way for, this is one country kind of tugging at that, pulling people over and allowing allowing PhDs who learn things here to go over there and build up new PhDs in their space, right? Sort of tugging some of our academic power as a nation state. So
being able to learn from that institutional memory, that organizational structure that we have here that maybe doesn't exist in France right now. There's so much you can learn from being on the ground and from actually talking to people. Not everything's written down in a book. You can't describe organizational structures very well in a book sometimes. So, I mean, this is a good way for them to engage with people from the best university systems in the world to then maybe mirror and fix problems within their own system with solutions that have worked here.
So, yeah. Well, all right. So moving on from that story about France to
another story about France.
To a startup company in France, Vive la France. A pair of, I should have done this episode in French just to practice. It would have been difficult, but I think I could have done it. I know about 4 words in French, so get ready for the French cut of all of our podcasts to all of our French listeners,
where I just go oui every so often
and smokes a cigarette.
you just hear that noise of when you're inhaling, just the burning really a little bit.
All right, all right.
cough
So a
here and
pair of
there.
French entrepreneurs have raised about 1.7 million euro, which is about $1.9 million, for a new electric propulsion system to address the small satellite market. The company is called ThrustMe, and it's a startup formed back in February by Anne Anasland and Dmitro Rafalski, two researchers from France's École Polytechnique Plasma Physics Laboratory and CNRS, the French National Center for Scientific Research. I'm not exactly sure where they're from, though, originally. But they claim their electric thruster has double the thrust of a regular miniaturized electric propulsion system at only 40% of the size. They also say that their thrusters are simpler to integrate into a satellite. The propulsion system has apparently been fully validated from thrust measurements performed by Onera, which is a French aerospace lab. They raised their funding from Kima Ventures and a collection of US and European investors in order to fund a technology demonstration in the next 18 months. The startup also plans to use the funding to double its headcount to 14 and to secure other customers. Now, I'm looking at their website, and I'm just going to read the summary of their thruster in comparison to a typical ion thruster. They say their solution is... It'll be in English. Here's the best English they come up with. They say their solution is a, quote, novel ion thruster operating with solid propellant that combines technologies from the space and semiconductor industries. The acceleration grids are biased with radio frequency voltages across a capacitor. Due to the different mass of ions and electrons, the plasma acts as a diode and the capacitor charges up or self-biases. The resulting DC voltage accelerates ions continuously while electrons exit during a short period within the RF cycle. This leads to a significant simplification and advantages over classical ion thrusters while still keeping similar or even better performance. The use of a solid propellant with a high vapor pressure, such as iodine, removes the need for high pressure storage and complex valves for flow control. That sounding like English to you?
Well, you said the word biased, and it's going to be like the media and extremely biased. This negative press cafefe. So could you explain to me a little bit about, I know a little bit about ion thrusters, but I think maybe for me and for our listeners, explain to us what some of that means. Like what is the difference between an ion thruster then and this solid matter or solid source? What even just use the right terminology so I'm saying this stuff right.
So
I can sound smart at parties.
Let me try and break this down a little bit in like 3 minutes. But the benefit of all of that is that they can make really tiny thrusters, right? So let me talk about the benefit. They claim that the solution can provide the necessary thrust and high specific impulse to do high Delta V missions using only about 5% of the satellite mass and volume, while still being able to carry out orbit transfers in just a few weeks. And by orbit transfers, they just mean moving a satellite from one orbit to another. So as far as how ion thrusters work, an ion thruster ionizes propellant by adding or removing electrons to produce ions. Most thrusters ionize propellant by electric bombardment, which is a having a high energy electron collide with a propellant atom. So negative charge, neutral charge, having those two collide. That releases electrons from the propellant atom and results in a positively charged ion. The gas produced consists of positive ions and negative electrons in proportions that result in no overall electric charge, and that's called a plasma. So that gas that's produced is called a plasma, or that pseudo gas. The plasma is kind of a different state of matter, and it has some of the properties of a gas, but it is affected by electric and magnetic fields. Some common examples of a plasma are lightning and the substance inside fluorescent light bulbs. And basically what it seems like they're doing here is that they're taking iodine I'm sorry. Yeah. They're taking what appears to be iodine, which is a solid propellant with a high vapor pressure, and attempting this exercise because iodine will remove the need for any high pressure storage, which allows them to be able to host this in a much smaller apparatus. That's the best explanation I can do in 3 minutes.
I got a bit of a glimpse of it, but I want to read more now.
Yeah.
So where can I go? Where can I go to read a little bit more about some ion thruster technology?
Ion thruster technology. You can go to NASA. Actually, NASA has a ton of pages on ion thruster technologies because they've been working on ion propulsion for a while now. If you go to nasa.gov/center/Glenn/about, you can surf to the NASA ion propulsion page and they'll tell you all about it.
Great.
So, ion propulsion, past, current, and future. So props to Thrust Me, which is an interesting name for a company. But it's great to see the
Thrust Me. It's a great name.
It's great to see space startups popping up all over the world and seeing how seeing how these companies play a role in overall commercial space, even though these folks will likely have both commercial and government customers.
Yeah. And remember, the Founder Institute is trying to get 500 new space startups by 2025. So
it's true.
This, as you can see or hear, there's a lot of parts of space that aren't just the launch vehicles. There's a lot of stuff that we need to figure out, and a lot of ways that it can be, some dual use technology for civil, commercial, or civil and defense, or, tri-usage technology.
Yeah,
so
absolutely.
Triple usage technology.
So moving on to coming soon to space.
And very soon, that is. That is 2 months from now.
Very soon and very far away. Actually, there is something in here that's very soon. So let me stop burying the lead. For the first time in 99 years, a total solar eclipse is going to cover the nation. It's the apocalypse. Run.
Wait, are we all going to die?
No. We're all going to die.
The end is nigh.
Yeah. I see what you did there. But yeah, we're going to have a total solar eclipse will cross the entire nation on August 21st. And so it's going to be, and I'm looking at this chart, this lovely chart that I got from NASA at AwesomeCon, and it's going to be at about 2:40 Eastern Standard Time. It's going to be right in the northern Georgia, western South Carolina region. It'll be visible from there. And so that's probably the closest time that we'll actually be able to see it. It's going to start at 10:20 Pacific time, which is at 11:30 Mountain Time, 1 o'clock Central Time, 2:40 Eastern Time. Okay. So it's going to cross the nation on August 21st, and at 1 p.m. on this Wednesday, when you were listening to this, stop listening to this and tune into NASA's webcast, because they're going to be hosting a webcast from the museum in Washington, D.C. The event's going to air live on NASA television and stream on the agency's website, and they'll have representatives from NASA, other federal agencies, and science organizations, all trying to provide important information about viewing safety, travel, and just the overall science of it. So make sure to tune in. Over the course of the sky is going to get very dark over the course of 100 minutes. And about 14 states across the U.S. will actually be able to experience that darkness for more than 2 minutes in the middle of the day. So it's going to be weird. You're going to want to know what to do. Don't get caught by surprise.
Yeah,
Listen to the webcast.
Yeah, you need to be listening to this webcast. We're going to put a link. So there's a link to the briefing that's coming up. And then if you want some more information, there'll also be a link to a space.com article that details some information about, when the the eclipse is going to be passing through your area, what it will look like, what to be prepared for, as well as a bunch of other articles linked in there. So this is going to be awesome. I still don't have a plan. So if people in the comments want to go somewhere with me, maybe that'll be the raffle, is you get to hang out with me.
I'm not exactly sure where I'm going to be at the time. So
yeah. So how about
what state I'm going to be in? There's a very real possibility that I'll be somewhere in the Southwest at that point in time. So we'll see if I'm even close to it.
Well, how about everybody comment on this video with where you're going to be, and if you want us to come with you, and if we can have a sleeping bag and maybe some snacks.
So that's all I've got for coming soon to space. We have an awesome solar eclipse, and yeah, that's about it.
Yeah.
You got anything else, Jack?
Nope. That is it on my end. Actually, a couple cool things that are coming up. Asteroid Day is June 30th, which will have an episode coming out next week. Before that, we'll probably talk about it then as well. Go see the Bill Nye film. Get tickets for AwesomeCon next year when they go on sale.
Definitely get the tickets for AwesomeCon next year when they go on sale. It's
tons of fun.
Absolutely
and Planetary, I will give you a little glimpse as to what we're going to be doing next year. It's going to be awesome. So come by the Planetary Society booth next year.
Are there any Planetary Society events coming up?
Nothing as of right now. I'll make announcements as it becomes available. But we're looking at some dark sky nights sometime in July, potentially. Maybe doing a happy hour for all of our new listeners to this and new followers of the society. So again, maybe not even again. I don't think we've said this yet. But thank you to everyone who is a new listener to the podcast. Please, drop us a like on Facebook. Make sure you follow us on Twitter. Comment on iTunes. Rate us on iTunes. Overcast, right, is the other one that you should do something with. Sign up for the email list. We try to have a very active community of supporters and listeners. So be sure to do all those fun things and engage with us. We're here to talk to you.
Mm-hmm. I've got one more. This is the event that I kept saying, isn't someone doing a night sky night, a night sky party? On June 23rd, there is a group that is going out to the Shenandoah National Park with with what appears to be a series of telescopes. So take a look on Facebook. It's by the group Shenandoah National Park Lodging. They're going to be taking a look at the night sky. So awesome. Make sure to take a look. Shenandoah is a great area.
If people are listening to this on Wednesday, right?
That's true.
All
if
right.
You're looking for something to do on Friday night, drive 2 hours to the Shenandoah National Park to Virginia.
Nothing cooler than the stars.
Otherwise, there will be another one on August 18th.
Sweet.
So, okay. Now I'm done.
All right. That's it. We're done. We're just over an hour long, this episode. So again, thank you all for listening. As always, I'm Jack.
And I'm Newton.
Ad Astra.